Hello, B3 Burner, and it is once again time for a Stellarium video. This time we have an evening planetary conjunction coming up in less than 2 weeks. I'm talking about Jupiter and Saturn, and the reason this is significant is that these two planets only conjunct about once every 20 years. Last time was late May 2000, and after this month, the next time won't be until early November 2040. The huge headway between conjunctions is because both planets' orbits are so far away in their revolution around the Sun relative to Earth that it takes that long for Jupiter to move ahead and lap Saturn on the following go-around. Each planet one orbit inbound revolves faster than its neighbor the next orbit out. So it's Jupiter passing Saturn, going eastbound. It might look the opposite way as we see the nights progress, but it's relative motion because of Earth's revolution and rotation. We won't get into that now. Maybe at some point I'll cover that subject specifically later. What makes these planets so special is that they both have some outstanding features. Here, let me center it on the screen. Jupiter, with its broad bands and its, well, you can't see it now, but it has a, well, there it is, sort of its pink eye. Yeah, Jupiter has pink eye, right? And Saturn, for its distinctive single ring, if you can look at them through a telescope. If you can't look at them through a telescope, you can still see them with the naked eye. Being right next to each other and Jupiter fairly bright, it will strike you as a bit unusual, though they may look not too different from regular stars. Maybe slightly brighter, but not much. Here, let's progress this so that it's a little darker. We'll move to about 5:30 my time. 5:45, why don't we pick? That puts it between 15 and 20 degrees above the southwestern horizon. The only downsides are that Saturn is much dimmer than Jupiter, so it will not stand out as clearly, but can still be seen. And the Sun is rapidly moving from west to east toward them, so at the point of conjunction, how am I going to show that? I'll go back to 2017. Here, why don't we do this? Point of conjunction will go to December 20th and or 21st. We'll leave it at 20th. I'll turn off the Earth. We'll as I struggle to use this program. There you go. You can already see the angular distance draw between the conjuncted planets and the Sun. There's only a 30-degree difference between the two of them, meaning that gives you little time to see them after sunset before they too themselves also set. Beginning earlier this year, the two planets have been chasing each other across the night sky, and now the dusk sky. They've never really been that far apart, relatively speaking, but now Jupiter is finally closing in. December, they have been getting closer still. The night of December 16th, let's go ahead to it, 14th, 15th, 16th. Look for the waxing crescent moon to be below the two planets by about 5 degrees. So there we go. Waxing crescent moon, 5 degrees, take my word for it. Because of its proximity, the moon makes a nice reference point in which to help pick the planets out. Move ahead 4 days. 4 nights later, 17th, 18th, 19th, 20th, you can see that the two planets are one right on top of the other, or appear to be. Let's pull in the celestial grid to determine what constitutes a conjunction. This is a line of celestial longitude, also known as a line of right ascension. When these two line up parallel to this line is when we have an actual conjunction. You'll notice that December 20th, it's a little too soon. December 21st, Jupiter is already past Saturn. It's a little too late. So what does that mean? Well, it means here on the west coast of the United States, the actual conjunction point does not line up neatly with either night. One night slightly too early, the following night too late. This is not unusual. The planets are moving against the celestial grid while the Earth is rotating. So if I don't see the exact conjunction point, chances are people on the opposite side of the Earth from me are seeing it in perfect alignment at their local dusk. Look low in the southwestern sky about 15 to 20 minutes after sunset, when the stars begin coming out, and you should see them 15 to 20 degrees above the southwestern sky. If you have no obstructions in that part of the sky, you can clearly see down to the horizon. You may have about an hour and a half at most to see it. So we'll go, let's back up to 5 o'clock, 6 o'clock. Oh boy, it dropped down fast. Bear in mind that once you get down to 5 degrees, your chances of obstructions increase markedly, and the back end of that window of time may be dark and unobstructed by twilight, but bear in mind the lower they drop, the more the atmosphere at the horizon will dim them in the sky, so don't wait too long. Well, I hope you enjoy the conjunction if you're out to see it, and for now I'm B3 Burner saying so long.